Welcome to Numbers Simplified. In this channel, we seek to simplify and solve numerical problems. Today, we're still continuing with the differentiation series. And today, we'll be looking at the substitution method, specifically the sine function. And take note, this is part 17. So make sure to check out all the other videos prior to this part, so that you don't miss out on any of the differentiation approaches. I also encourage you to check out all the other playlists that we have compiled thus far in this channel. Now recall, if y of x is equals to sine x, then the dy dx is equal to cos x. And in general, if y of x is equals to sine of f of x, then the dy dx becomes f prime of x times cosine of f of x. Let us verify what we have. We are going to derive the dy dx. Now, if y of x is equals to sine of f of x, using the chain rule method that we covered in this differentiation series, this was video part 3, we used the substitution method in order to verify. That is step number 1. U is equal to f of x, and that would mean that the du dx becomes f prime of x. The step 2 would be, since we have substituted for the f of x with the u, y becomes sine of u. And we see that the dy du becomes cos of u from what we have on the left-hand side on step number 2 and 3 on the left-hand side. Then the dy dx becomes dy du times du dx. And of course, substituting for the dy du that we obtained in step number 2, which was cos u, times the f prime of x that we obtained in step number 1. We can go on further to substitute for the u, since we know what u is in terms of x. F of x it is. Therefore, dy dx becomes f prime of x times cosine of f of x. And that shows what we have on the left-hand side. Now, with that in mind, we can use the shortcut method, but for today, we are going to focus on the substitution method. Let us take a look at example 1. If y is equals to sine of 2x plus pi over 3, find dy dx. And of course, the solution. If y of x is equals to sine of 2x plus pi over 3, using the chain rule, we are going to let u be the inner function in the sine function. And the inner function is the 2x plus pi over 3. Now the derivative of u with respect to x, du dx, is equal to 2. This would imply that the y now changes to become sine u. Therefore, the dy du becomes cos u, or cosine u. Then the final step would be dy dx. And we know what dy du is from the second step, cosine u, times the du dx, which we obtained from step number 1 at 2. Then we substitute back for what the u represents from step number 1. Therefore, the dy dx becomes 2 cosine of 2x plus pi over 3. As easy as that. Let's take a look at example 2. If y is equals to e to the sine 2x, find dy dx. The solution. If y is equals to e to the sine 2x, using the chain rule, video approach. That was part 3. We are going to let the inner function, which is the sine 2x, and that would imply that u is equals to sine 2x, and the du dx becomes 2 cosine 2x, according to what we obtained in part A. Or alternatively, we can look at the shortcut, the quick and easy method. We see that we find the derivative of what is inside the sine function, which is a 2, times the derivative of the sine itself, which is a cosine. Then we return what was inside the cosine, which is the 2x. And alternatively, we can use the substitution method. Let us use v this time around because the u is for the bigger function. But now we're dealing with the inner function inside a function. So we're dealing with the sine function, which is within an exponent function. So let's let v be 2x. This means that the dv dx becomes 2. And of course, the u becomes sine v because v is 2x, implying that the du dv is cos v or cosine v. Now, according to the information we have on the left-hand side, so the du dx becomes du dv times dv dx. Now, we have obtained this, the du dv we obtained, as well as the dv dx we obtained. We multiply the two, we get 2 cosine 2x. Now that we have our du dx, we move on to step number 2. Y is equals to e to the u, since we have substituted for sine 2x in the first step in red. Therefore, and recall from the exponential differentiation video, that was part 15, the dy du becomes e to the u. Therefore, the dy dx is equals to dy du times du dx. dy dx is equals to e to the u times 2 cosine 2x, because we're simply substituting for the dy du and the du dx. Now, we substitute back for the u so that we get 2 cosine 2x e to the sine 2x as our final answer. And if you have made it thus far, I say congratulations to you. And I leave you with the following task. Make sure to write your questions and your answers in the comment section. Thank you so much for watching Numbers Simplified. Make sure to subscribe, like, and share. And remember, God loves you.